In a galaxy far, far away, there is a civilization so advanced that it harnesses the power of entire galaxies, controlling the very fabric of the universe itself. It's a concept that has captivated the minds of scientists and dreamers for decades. But what if I told you that there's a limit to how advanced a civilization can become? That's where the Kardashev scale comes in. A cosmic yardstick that measures the technological prowess of civilizations based on their energy consumption. As humanity stands on the brink of a new era, with AI and other groundbreaking advancements propelling us forward, we can't help but wonder, how far can we go? Will we ever reach the dizzying heights of a Type 3 civilization? Or is there a fundamental barrier that even the most advanced species cannot overcome? Let's start our journey by examining the very beginning of the Kardashev scale. Type 0 civilizations. This is where we, the human race, currently find ourselves. A Type 0 civilization is characterized by its ability to harness and utilize energy sources available on its home planet, such as fossil fuels, renewable energy, and even nuclear power. However, the total energy consumption of a Type 0 civilization is still insignificant compared to the amount of energy the planet itself receives from its parent star. You might be wondering, how do we know where Earth stands on the Kardashev scale? Well, the answer lies in the way we measure a civilization's advancement. The Kardashev scale is based on the amount of energy a civilization can harness and put to use. Currently, Earth's total energy consumption is estimated to be around 18 terawatts, which is roughly 0.16% of the total energy Earth receives from the Sun. This may seem like a small fraction, but it's important to remember that we've come a long way since the dawn of human civilization. Our journey from the discovery of fire to the invention of the steam engine, and from the harnessing of electricity to the splitting of the atom, has been a testament to human ingenuity and our ability to adapt and evolve. However, as we look towards the future, we can't help but wonder, what will it take for us to reach the next level on the Kardashev scale? The leap from a Type 0 to a Type 1 civilization is no small feat. It requires a complete mastery of the planet's energy sources and a level of technological advancement that allows for the efficient use and distribution of that energy. To put things into perspective, a Type 1 civilization would need to consume around 10 to the 16 watts of power, which is roughly 100,000 times more than what we currently use. But the challenges we face in reaching Type 1 status go beyond just energy consumption. We must also consider the social, political, and environmental hurdles that come with such a massive shift in our civilization's structure. As we continue to grow and advance, we'll need to find ways to overcome issues like climate change, resource depletion, and social inequality, all while pushing the boundaries of what's possible in terms of technology and innovation. It's a daunting task, but one that we must face head-on if we hope to continue our journey through the cosmos. And who knows? Perhaps the key to reaching Type 1 status lies not just in our technological advancements, but in our ability to come together as a species and work towards a common goal. If you're liking the video so far, you should consider subscribing to the channel and help us create better content and reach more explorers out there. Now back to the video. As we continue our journey through the Kardashev scale, let's explore the next step in a civilization's evolution: the Type 1 civilization. A Type 1 civilization has achieved total control over its planet's resources, harnessing the full potential of its homeworld's energy. This is a significant leap from the Type 0 civilization we discussed earlier, and it comes with its own set of challenges and opportunities. Imagine a world where every inch of the planet is optimized for energy production and utilization. From vast solar arrays stretching across deserts to advanced geothermal power plants tapping into the Earth's core, a Type 1 civilization would have mastered the art of sustainable energy on a planetary scale. But the control over resources doesn't stop there. A Type 1 civilization would also have the ability to manipulate the planet's weather patterns, control its climate, and even engineer its ecosystems to suit its needs. This level of control may seem like something out of a science fiction novel, but it's a very real possibility for a civilization that has reached this level of advancement. But what would be the consequences and benefits of achieving Type 1 status? On the one hand, having complete control over a planet's resources could lead to unprecedented levels of prosperity and stability. Imagine a world without energy scarcity, where every individual has access to clean, renewable power. This could lead to a significant reduction in poverty, hunger, and disease, as well as a decrease in global conflicts over resources. However, with great power comes great responsibility. A Type 1 civilization would need to be incredibly careful in how it manages its planet's resources, ensuring that it doesn't deplete them or cause irreparable damage to the environment. There would also be significant ethical considerations to take into account, such as the potential for abuse of power and the need for fair distribution of resources. So, what might a Type 1 civilization look like in practice? One hypothetical example could be a planet-wide network of advanced AI systems that optimize energy production and distribution in real time, ensuring that every corner of the world has access to the power it needs. Another example could be the development of advanced terraforming technologies that allow for the creation of new habitable zones on the planet, expanding the available land and resources for the civilization to utilize. When compared to our current human technology, the capabilities of a Type 1 civilization may seem like something out of a distant future. However, we're already taking steps in that direction. The development of renewable energy technologies like solar, wind, and hydropower is bringing us closer to a more sustainable future, while advances in fields like bioengineering and nanotechnology are opening up new possibilities for resource management and optimization. As we venture further along the Kardashev scale, we encounter the awe-inspiring concept of a Type 2 civilization. These advanced beings have not only mastered the resources of their home planet, but have also harnessed the immense power of their host star. The sheer scale and technological prowess required to achieve this level of energy mastery are truly mind-boggling. To capture the total energy output of a star, a Type 2 civilization would need to employ some of the most ambitious and innovative methods ever conceived. One such hypothetical megastructure is the Dyson sphere, named after the renowned physicist Freeman Dyson. This colossal structure would completely encompass a star, capturing every last photon of energy it emits. The Dyson sphere would consist of a vast array of solar collectors, each one designed to absorb and convert the star's radiation into usable energy. Another method a Type 2 civilization might employ is stellar engineering. This involves directly manipulating the star itself to optimize its energy output and extend its lifespan. By carefully controlling the star's fusion reactions and managing its magnetic fields, a Type 2 civilization could potentially extract even more energy from their host star while ensuring its long-term stability. Some astronomers have suggested that unusual patterns of light and infrared radiation around certain stars could potentially indicate the presence of a partial Dyson sphere. For example, the star KIC 846285, Tabby's star, has exhibited strange dimming patterns that have led some to speculate about the presence of an alien megastructure, although other explanations such as comets or dust clouds are more likely. The implications of achieving Type 2 status are staggering. With access to such a vast energy supply, a civilization could undertake projects on a scale that would make even the most ambitious Type 1 endeavors seem trivial. For example, a Type 2 civilization might construct vast space habitats that could house billions of individuals, creating artificial worlds that rival the size and complexity of entire planets. Perhaps most exciting of all is the potential impact on interstellar travel. With the energy output of an entire star at their disposal, a Type 2 civilization could develop propulsion systems that would allow them to traverse the vast distances between stars in a matter of years or even months. This would open up the possibility of colonizing other star systems and establishing a true interstellar empire. Of course, the challenges involved in reaching Type 2 status are immense. The engineering and technological hurdles alone would require a level of advancement far beyond anything we can currently imagine. There are also significant ethical and philosophical questions to consider, such as the potential impact on the star's planetary system and the long-term sustainability of such an enormous energy harvesting project. But for a civilization that has already mastered the resources of its home planet, the lure of the stars may prove too strong to resist. Advancing on the Kardashev scale, we now find ourselves in the realm of the truly cosmic. A Type 3 civilization is one that has achieved mastery over the energy output of an entire galaxy. The sheer scale and power of such a civilization are almost beyond human comprehension. To control the energy of a galaxy, A Type 3 civilization would need to harness the power of billions of stars, each one a vast energy source in its own right. This would require technologies and engineering feats that are currently the stuff of science fiction, such as the ability to manipulate the very fabric of space-time itself. The influence and reach of a Type 3 civilization would be staggering. With access to the resources of an entire galaxy, they could undertake projects that would dwarf even the most ambitious Type 2 endeavors. For example, a Type 3 civilization might construct vast networks of wormholes or other faster-than-light transportation systems, allowing them to traverse the immense distances between galaxies in mere moments. However, the existence of such advanced civilizations raises an intriguing question, known as the Fermi paradox. Named after the renowned physicist Enrico Fermi, this paradox asks a simple yet profound question. If advanced civilizations are indeed possible, why haven't we seen any evidence of them? The Fermi paradox suggests that, given the age and vastness of the universe, if advanced civilizations were common, we should have detected some sign of their existence by now. The fact that we haven't could indicate that such civilizations are incredibly rare, or that there are factors limiting their development or expansion. One possible explanation for the Fermi paradox is the idea of the Great Filter. This hypothesis suggests that there may be some insurmountable obstacle or barriers that prevent civilizations from reaching the higher levels of the Kardashev scale. This could be anything from the difficulty of developing advanced technologies to the inherent instability of galactic-scale civilizations. Despite the challenges and uncertainties, some theorists have speculated about even higher levels of the Kardashev scale, beyond Type 3. A Type 4 civilization, for example, might have mastery over the energy output of an entire universe, while a Type 5 civilization could potentially harness the power of multiple universes or dimensions. These hypothetical civilizations are the stuff of pure speculation and are currently beyond the realm of scientific investigation. However, they serve to illustrate the truly mind-boggling scale of the cosmos and the potential for life and intelligence to evolve in ways we can scarcely imagine. We have some examples of structures in the universe that may represent the discovery of advanced types of civilizations. The large-scale structure of the universe is characterized by a web-like network of galaxies and dark matter, known as the cosmic web. Some researchers have proposed that advanced civilizations might be able to manipulate these filaments and construct massive superstructures that span entire galactic clusters. While there is no evidence to support this idea, it remains an intriguing possibility for the activities of a Type 3 or higher civilization. The Buddha's Void is a vast, nearly spherical region of space that contains very few galaxies. With a diameter of around 330 million light-years, it is one of the largest known voids in the universe. Some speculative theories have suggested that the void could be evidence of a Type 3 or higher civilization that has harvested the energy and resources of entire galaxies, leaving behind a region of empty space. However, most astronomers believe that the Buddha's Void is a natural formation and not the result of any intelligent activity. As we ponder the possibilities of Type 3 and beyond civilizations, it's important to keep in mind the limitations and challenges that would come with such advanced levels of development. The energy requirements alone would be staggering, and the complexity of managing and sustaining such vast civilizations would test the limits of any species, no matter how advanced. Moreover, there are fundamental questions about the nature of the universe itself that would need to be answered before such civilizations could even be considered possible. For example, is the universe finite or infinite? Are there limits to the amount of energy that can be harnessed, or the speed at which information can be transmitted? These are questions that push the boundaries of our current scientific understanding and may ultimately determine the limits of what is achievable on the Kardashev scale. As we've explored the Kardashev scale and the incredible potential for advanced civilizations, it's natural to wonder just how far a species could progress. Could there be a Type 7 civilization? One that has transcended the very boundaries of the universe itself? To answer this question, we must first define what a Type 7 civilization might look like and the requirements for its existence. A Type 7 civilization would be one that has achieved mastery over the fundamental forces and laws of the universe. They would have the ability to manipulate space, time, matter, and energy on a scale that is currently incomprehensible to human science. In essence, A Type 7 civilization would be akin to a godlike entity, with the power to shape reality itself according to their will. However, as we delve deeper into the implications of a Type 7 civilization, we begin to encounter the fundamental limitations of the known universe. These limitations arise from the very laws of physics that govern the cosmos and define the boundaries of what is possible. One such limitation is the speed of light. According to Einstein's theory of special relativity, nothing in the universe can travel faster than the speed of light. This places a hard limit on the ability of any civilization, no matter how advanced, to traverse the vast distances of the cosmos. Even with technologies such as wormholes or warp drives, a Type 7 civilization would still be constrained by the immense scale of the universe and the time required to travel between distant points. Another fundamental limitation is the concept of entropy. The second law of thermodynamics states that the total entropy of a closed system always increases over time. In other words, the universe is constantly moving towards a state of greater disorder and chaos. This has profound implications for the long-term sustainability of any civilization, as it suggests that the very fabric of the universe is inherently hostile to the kind of stability and order that would be required for a Type 7 civilization to exist. Moreover, there are questions about the fundamental nature of reality itself that pose challenges to the idea of a Type 7 civilization. For example, some theories in quantum physics suggest that the universe may be inherently probabilistic and uncertain at the most basic level. This would make it impossible for even the most advanced civilization to achieve perfect mastery over the cosmos, as there would always be an element of randomness and unpredictability to contend with. There are also philosophical and logical paradoxes that arise when considering the implications of a Type 7 civilization. For example, if such a civilization had the power to manipulate reality itself, could they create a situation in which their own existence was impossible? Such paradoxes suggest that there may be inherent contradictions and limitations to the very concept of a Type 7 civilization that go beyond the realm of scientific investigation. Ultimately, while the idea of a Type 7 civilization is certainly fascinating to contemplate, the current understanding of the laws of physics suggests that it is likely impossible. The fundamental limitations of the universe, from the speed of light to the arrow of time, place hard boundaries on what is achievable, even for the most advanced civilizations imaginable. This doesn't diminish the incredible potential for progress and advancement that exists within the Kardashev scale. Indeed, even a Type 1 or Type 2 civilization would be capable of feats that are currently beyond human imagination. But it does serve as a reminder that no matter how far we advance, there will always be limits and challenges to contend with, and that the universe itself may have fundamental constraints that even the most godlike entities cannot overcome. Trying to find life beyond our touch has always fascinated humanity, and there are a few candidates that were found by the Kepler Space Telescope that give us hope on answering our most ancient question: are we alone in the universe? On the video appearing on your screen now, we dive deeper into that. But we want to know from you, what do you think is the answer for that age-old question? Leave it here in the comments and take the opportunity to like the video and subscribe to the channel for more videos like this.